Hi guys, another example today to show you how to quickly draw bending moment diagrams and work out your reactions based on that. As you can see, I've already started from the right hand side because it's got a point load on the cantilevered end. That's why we've got the triangle here, and the moment here is just simply P times L. 2 times 6 gives 12 kilonewtons meter. And as usual, I've dashed it out from point A to point B because I know at the point A, the bending moment is 0 because it's pinned. And from point A to C, this segment here, we've only got a reaction coming onto point A, and between A and C, there's no other loads. And based on the shear force, we know that this is just going to be rectangular, a straight line, because the shear force is a constant. When the shear force is constant and your bending moment as an integral of that shear force is going to be a slope. So we can confirm that from A to C is going to be slope. So the question left us is the segment, the C and the B. And we know it's going to be, because your load is UDL, and we know when the load is UDL and your shear force diagram is going to be sloped, and your moment is the integral of the shear force is going to be a parabolic shape. That means you can connect from C to B. It's going to be like that. But the question is whether the lowest point is going to be above or below. We are not sure. However, we can, using trigonometry, to work out the point here. At the point here, let's call it E. Because if we got 12 kilonewtons at the top here, and this is sort of 2/3 away from 12. This is going to be 8, and here is going to be 4. Right? And then we just work out what is the distance, what is the parabolic profile, the magnitude from here to here. And we can get that using the equation omega L squared over 8. That gives 3 times 4 squared over 8, and this is 16, that's 2, that's a 6 kilonewton meters. So the bottom here is a 6. Now we can connect this here. Oh, sorry, this portion here is 6. This magnitude is 6. So the lowest point here is 8 minus 6 equals 2. So that lowest point between segment C and B, that is 2. Now we've worked out the bending moment for each segment. Now we just need to work out what is the reactions here. So from the last episode, as I explained, on the right hand side, and any support, if we've got a left and right. On the right hand side, if we've got a 6 kilonewtons, no drama, that is going to be 6. And let's look at it on the left hand side, because you want to work out from the triangle first, but here is going to be a parabolic. It's a curved line. The slope doesn't work on here. However, it's going to be worked from here, so we can get the slope. This is going to be 4 divided by 2. This is 2 kilonewtons. So the reaction A is 2 kilonewtons. And between A and B, we've got total load of 3 times 4 equals 12 kilonewtons, which left 10 kilonewtons on the B, because 2 plus 10 equals 12. So in this case, we know the reaction at the B is going to be 16 kilonewtons, and the 2 kilonewtons on the A, sorry. So this is how you quickly work out the bending moment diagrams, and using the bending moment diagram, using the slope, and then you can work out the reactions quickly. Okay, if you have any questions, you can make a comment. Otherwise, I'll see you on next video. Thanks.